All right, welcome back everyone. Today we're going to be looking at 7.7, which is the last little part of our chapter 7, looking today at how to find inverses of functions and relations. So first of all, if we were to describe what is an inverse, in the most easy terms that I can think of is a function or relation that undoes the original relation or function. Now, I'm going to use the word function a lot more than I am going to relation, but what inverses are things like squares and square roots. We know that a square will undo a square root. So if we were to do the square root of x squared, that undoes the square. So the square root will undo a square, just like a square will undo the square root. They're inverses of each other. We know addition undoes subtraction, or subtraction undoes addition. Multiplication undoes division. So these are kind of like our inverse operations. So if we were to move on here, we would say, okay, they're functions that undo each other. There's a very important notation that goes along with this, that once you see the notation, you need to always understand that this represents the inverse of a function. And if you have the function f of x, the inverse is when we put this little -1 sign kind of as an exponent on the f. So f inverse, that's what this is the inverse of function f. That is our notation for the inverse of a function. Very important that you understand what that means when they ask you to find f inverse. But they're going to ask you to find f inverse, but they're just going to say find this thing, f to the -1 of x. And what this ends up doing is saying that both f and f inverse are inverses of one another. So f is actually the inverse of f inverse. Right? So if we were to go on looking at a relation as an ordered pair, we might recall looking at things like this. This is a relation with 4 separate points. Now, in order to find the inverse of the relation, all you have to do is swap the x and y coordinates. And when you swap the x and y, you get the inverse of the relation, being instead of 0, 1, we have the point 1, 0. Instead of 2, 3, we have 3, 2. And likewise down the list. Now that swapping of x and y is very important as we go forward into looking at functions and finding the inverse of a function, which is where we're at now. So that swapping of x and y is very, very important. It's one of our it's actually our first step that we're going to be doing when we actually try to calculate the inverse. So if you're asked to find the inverse of a function, of an equation, you're going to swap the x and y in that equation. And I'm going to remind you, because we're going to look at a couple examples like this, I'm going to remind you that f of x is the same thing as y. So there's going to be some times we need to rewrite f of x as y in order to do this type of computation. Once you swap x and y, you're needing to solve for y once again. And once you have solved for y, that is your new inverse. All right, so let's look at some examples. Let's say we had the example. Let's just start with f of x is equal to 2x minus 3. All right, so we need to replace f of x with y just because the idea is to swap x and y. So we're going to say this is y equals 2x minus 3. You'll notice this is a linear function. And what we need to do now is we need to swap x and y. We need to just trade places with x and y. So this is going to be saying x equals 2y minus 3. So that is the swapping of x and y. And now we need to solve for y. So we need to get y by itself. So we're going to add 3. We're going to get x plus 3. We're going to divide by 2. And we're going to say this is y equals x plus 3 all over 2. Another way to write this is 1/2 x plus 3/2. And that's the solving for y. And in green here, that new equation is your inverse. So given f of x is equal to 2x minus 3, f inverse of x is equal to this new linear function, 1/2 x plus 3/2. So these are inverses of one another. Let's try another one. Let's say we had the equation y equals x squared minus 3. So again, we need to swap x and y, just trade places. So we get x equals y squared minus 3. And then we have to go through the process of solving for y. So we're going to add 3, add 3. We get x plus 3 equals y squared. And in order to get y by itself here, you are going to need to square root. So we get y equals the square root of x plus 3. And what we need to remember is that when we take the square root of both sides, we get both a plus and a minus to represent the inverse. So this is not actually a function because it's actually two separate equations. We have the positive square root and the negative square root. But we did just find the inverse. So the inverse is plus or minus the square root of x plus 3. Let's do one more like this before we move on to the last piece. So we're going to say y is equal to the square root of x. Actually, let's change that a little bit. Let's say do the square root of 2x minus 1. So as it has been, we need to swap x and y. So we get x equals the square root of 2y minus 1. Once you have swapped x and y, you need to solve for y. So in order to get rid of the square root, you're going to square both sides. And we get x squared is equal to 2y minus 1. And then we need to do the easy pieces of getting rid of the rest of the stuff around the y. So we're going to add 1. X squared plus 1 equals 2y. Divide by 2. And we get the inverse. Y equals 1/2 x squared plus 1/2. Remember that 2 divides into both things. So we have 1 over 2 and 1 over 2. And that is our inverse. All right. The final thing that we need to cover here is looking at the composition of two inverse functions. As a basic definition, when you compose inverses, so if f and f inverses our inverse functions, then when we compose the two functions, when we say f inverse of f of x and f of f inverse of x, we remember that idea that inverses cancel each other out. And if we do that, we can know that the composition of two functions that are inverses will result in the answer of x. So there's two different questions that could be asked here. The first could be a very simple, given f inverse and f, if I was to just ask what is f inverse of f of 10, I wouldn't even need to know what the function is. I did not need to know what f is as long as I know that these two functions are inverses. The answer is simply 10. Now there are some little caveats to that. 10, you have to be able to plug 10 into the original function. All right, so if we had the function where f of x is equal to 1 over x minus 10, 10 is the one number that we can't plug into f of x. So we actually wouldn't be able to do this problem. We would say D and E does not exist. But in this case, just looking at simple f inverse of f of x, or f of 10, is equal to 10. The other thing we can do here is prove two functions are inverses. If we had f of x is equal to 10x minus 10, and I had g of x is equal to 1/10 of x plus 1, I need to see if they're inverses. And in order to prove if two functions are inverses, I just do the compositions. So I do f of g of x, and I do g of f of x. Now, as we did in the last lesson, f of g of x says, let's take f of x and plug in g of x. So I'm going to take 10. Let's do this a little bit fancier here with some different colors. If I call g of x the red, so I'm going to take 10, which is part of f of x, and I'm going to plug in g of x. And I'm going to simplify. If I distribute this 10, I get 10 times a 10th, which is just 1. I get 10 times 1, which is 10, minus 10, and those 10s go away, and I get the value of x. So I'm halfway done. I have shown that the composition of f of g of x is x, and if the other one comes out to x, then I will be done. So again, let's do a little bit of color enhancement here. Let's call f of x a blue. And we want to take g of f of x. So I'm going to say 1/10 of f of x. So f of x is 10x plus 10, or 10x minus 10. And we have our plus 1. All right, we distribute. 1/10 of 10 is 1. 1/10 of negative 10 is negative 1. The 1's cancel, and we're left with x. So this means f of x and g of x are inverses. Because when they compose, they come out to x, which satisfies our definition. All right, so not a lot of different things going on here today with the inverses, or with the compositions. However, we're really looking at the inverses, how to solve for them, and really that idea of swapping x and y and solving for y. All right, that actually finishes us off today. We'll move on to your assignment slide. We'll be looking at this assignment for 7.7. Just remember that this is a 2-section quiz, so we're going to have lessons 6 and 7 on our quiz at the end of the week. All right, hope you learned something, and I will see you guys later.